Hi folks, this is a predictions video for the Leaving Cert Ordinary Maths Paper 2 for 2024. So what comes up every year. So generally I'm going to be going through topics which have come up in the last few years and which you should be familiar with and which should give you a point to start revising with. So what's included, so an overview of topics which have come up in the exam papers, then a list of recurring topics to focus on. I've got some worked solutions to exam questions. So all the solutions that I'm going to show here are from the 2023 paper. So you can see what came up last summer within these topics. And then I've got some links and QR codes. So they go to full video solutions and they're obviously worth looking at if you want to get in and see the solutions slower and or if you don't fully understand them, which you probably won't here because I'm going to be going through them pretty quickly. So this is generally what has come up, the general broad kind of topics of what have come up there in 2023 back down to 2020. But don't be too worried about what exactly I've called them here. I've just kind of looked at the question and I've called them whatever I kind of thought when I looked at the question, so there's nothing real exact or precise about what whatever words I've put in here. So I'm going to go through a number of topics now. The first one is coordinate geometry, and I've put down a list of words here. So distance, slope, midpoint, equation of a line, and then area of a triangle. So they should be familiar to you. They're on a page in the log tables and there's a formula for each one. So I've put them all into the one kind of topic here, or they are the same topic anyway, but just as one thing that you should be revising. So you'll see there in the question from last year, slope came up and distance came up, and it came up quite nicely there in part A. All you had to do was stick down the formula. The formula m is equal to y2 minus y1 over x2 minus x1, and then the square root x2 minus x1 squared and so on. There in the log tables, you just had to put them down, and then you just had to use the 2 points that were given at the top there. You didn't even have to read them off a graph or anything. And then the part B was equation of the line. So that came up as well, and it was just, they actually gave you the slope already. Now the slope was a fraction, which complicated things a little bit, but and they gave you the point there, so you can't really go wrong as long as you know what to put in and you're used to using the formula. So just get used to all of those formulae. Area of a triangle there, that's when you have to make one of the points into 0, 0. So you have to do a translation there first. So just look back at that. It's not just straightforward you putting it into the formula. There is something you have to do first there for that one, but the rest of them are pretty much subbing into formula. It's just being used to doing it and recognizing which one to use where. So you'll see there coordinate geometry has to come up as a topic anyway. So it was question 1 there last year, and then it was question 1 in 2022 as well. So slope came up again there, distance between 2 points came up again, and then there was a question on perpendicular lines. That's when the slope is where you flip it upside down and change it to a minus. That's one of the harder parts of that topic. You'll see in 2021 that equation of a line came up in part A of question 3. Then as the equation of a perpendicular line. So I was using the equation of a line formula. You'll see there actually in question 10 that year as well, it came up again, just plotting coordinates, plotting lines. Distance formula came up again. Verifying, find that a point is on a line, equation of a line again. So it's guaranteed. So, and then the question 20 or year 2020, distance between 2 points come up again, midpoint and area of a triangle come up that year. And so that's it. So next one I'm moving on to is correlation coefficient. So this is to do with scatter graphs or scatter plots. So this was the question from last year, and what you have to understand here is if the dots are going down from left to right, so if they're falling from left to right, like in A there, it's going to be a negative, has to be a negative correlation coefficient. If they're rising from left to right, like in B and in C, then it has to be positive. So that determines whether they're negative or positive. And then what you have to know then is that the closer it is to 1, the closer the dots will be together. So in B there, it's 0.95, and that's because the dots are all in close together, so that's showing a strong correlation coefficient. And then in C, it's only 0.6, so the dots are much more spaced out, but they're still rising from left to right, so there is a positive correlation there. So that's correlation coefficient. There's not much to know really with that. It's just knowing those things that I've said, and it's coming up there the last 3 or 4 years. So yeah, it was question 3B there last year in 2023. Then it was in question 7 in 2022 as in the part A. Then it was in question 5 in 2021. And then in 2020, I can't quite see it there at the moment, but you'll see definitely the last 3 years it's come up anyway. So 2023 back to 2021. So it's quite an easy question if it does come up, really, so it's worth learning how to do it. Right, the next one is circle. So I've summarized this into radius and center, and then subbing a point into the equation of a circle. So if you think about radius and center, first of all, this is the question that came up last year. So I've written the general equation at the top, very top there, the x minus h squared plus y minus k squared equals r squared. So the h and the k are always the center point. So that's what those represent, and then the r is obviously going to stand for radius. So in this question last year, it was just x squared plus y squared is equal to 25. So you see there's nothing beside the x there, or there's nothing beside the y. So that means the center has to be 0, 0, or you could learn off that when it's x squared plus y squared, always it has to be 0, 0. So whichever way you would have done it. And then the r squared is the 25, so therefore r has to be 5. So it's just knowing how to find radius and center, or you could be given the center and the radius and asked to write the equation of the circle. So that equation of a circle formula is in the log tables anyway. Second part there is subbing a point into the equation of a circle. So the second part here of part A was to show that the point 3 minus 4 is on the circle. So you'll see that they're just subbing in the 3 and subbing in the 4, and you'll have to do that quite a lot. It might give you, sometimes it might give you maybe 2k or something. So the point 2 comma k is on the circle, and they ask you something about it and you'll have to sub it in. So it comes up quite a lot where you're just putting a point into the equation, where you're just subbing a point into the x and to the y when you're given the equation of a circle. And also when you could be given the equation of a line, so same thing, you'll have to sub in a point, but it comes up quite a lot, so it's worth looking at where to do it and recognizing when to do it. So you'll see there in the circles question, generally always is, well, there has to be a circle question. So question 5 there in actually it was question 2, so question 5 is a circle as well, but it's still an area of a circle. So question 2 there in 2023, center and radius of a circle is in part A. And then same thing in question 2 in 2022 as well, center and radius of a circle. Then so question 4 in 2021 was, so you had to actually draw a circle first, and then you had to find the radius and the equation of a circle from that. So it's still using what I was just showing there, the centre and the radius. And then it was question 4 in 2020 as well, so finding the centre and the radius. So you see there, it's coming up every year. Right, this is probability, and probability is a big part of the paper. Paper 2, probability has to be on it. Arrangement is one kind of subtopic that is very common to come up. So you'd see there, this is what came up last year. In how many ways can the letters in the word camogie be arranged? So there's 7 letters there altogether. So that is simply just doing 7 factorial. So that just means 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's how many different arrangements. You could start going through them if you want, but knowing that that's 7 factorial saves you an awful lot of time. Then in the second part, how many arrangements start with M and end with one vowel? So the boxes here mean each letter, so there's 7 boxes there. So if it has to start with M, there's only one possibility for the first box, so that's why there's a 1 in that. And then end with a vowel, well, there's only 4 vowels in the word camogie, so that's why there's a 4 in the last box. And then the rest then is just 5, 4, 3, 2, 1. They're the options that are left. The last part of it is how many arrangements of 3 different letters can be made from the letters in the word camogie. So that's just using the NCR, that's the button on the calculator, that's why that's in a box there. That's the button that you're looking for on the calculator. So what you should be pressing there is 7 and then the NCR button and then 3. And that just means 7, choose 3. It means how many ways are there of choosing 3 when you're given 7. So that's all it is. So there's simple little things to remember there, but they'll save you a lot of time and kind of trying to figure things out or trying to do it out by hand. Just knowing how to use the calculator with those. So the factorial button and the choose button, the NCR button. So you see that was question 3 there last year. Then the same type of thing came up there in question 7, and there was a 2-way table for probability as well in 2022. And then there was a probability in 2020 in question 2021, question 2. And then question 1 in 2020. So arrangements is quite simple as well. It's one of the things that is a little bit more easier to get your head around than some other parts. So it's an important thing to know how to do. So next thing is trigonometry, and I'm breaking this up a little bit. So trigonometry is one of the big topics that has to come up on the paper. It's going to be a big part of paper 2, and it can be broken down into Pythagoras, SOHCAHTOA, and then sine rule and cosine rules. I'm going to go through all those 4. So I'm starting off with these 2, and this is what came up last year on Pythagoras, but it might have come up in other parts of the paper as well. So Pythagoras is something that you would have done even in junior cert, and it's just to do with working out a side. So when you're given 2 other sides of a right angle triangle, so use theorem of Pythagoras. So AC, when BC is 27 and AB is 105, so you're given BC and AB here, so you're given the long side and one of the short ones, and you're asked to work out the other short one. So that's why we subtract. So we square both sides and then we square root. So that's how to do Pythagoras. So it's to do with right angle triangles. So it's important to recognize when you see right angle triangles in any shapes on the whole paper, a lot of the time it's going to be using Pythagoras. And then SOHCAHTOA is also to do with right angle triangles. So you're asked to work out the size of the angle BAC here when the gradient of the road is 9. So that's 9 over 100. So that tells us that tan of x is equal to 9 over 100, because tan is opposite over adjacent. So opposite is BC and the adjacent is AC. And then we can do tan inverse. So again, there's a link there if you want to see it a bit slower. Sine rule is the next part of trigonometry. So here you're asked to work out the side or O or OR. So this is all about picking the opposite side. So you put any side here, I'm picking X and I'm putting it over sine of the angle opposite or the angle across, which is 87. And it has to be equal then to 20 over sine of the angle 5. You have to work out the angle 5 there. And that forms an equation, and then you can cross multiply is one way of doing it, or just move over to sine 87 and multiply like I'm doing here. So that's sine rule. And then the other one is cosine rule. So that's this formula. It's a squared equals b squared plus c squared minus 2bc cos a. So it's an awkward looking formula, but it's in the log tables again. And it's the biggest thing here to remember is that the two a's, the small a and the big A, the small a is going to be a side, and the angle, the big A has to be the angle across from that then. So here we're letting it be x, and you're just summing in the b and the c are going to be the ones that are both sides of the angle. So it's the 700 and the 800 here. And when you've got all those put in, then you've got an equation. I'm moving everything over to the left hand side here, the 49,000 or 490,000 and the 640,000. And then at the end I'm dividing across by 112,000 or whatever there. So that's cosine rule. So I'll just show you here where trigonometry is always coming up. So it was question 7 there, so you'll see it, Pythagoras, SOHCAHTOA, sine rule, cosine rule, they all come up in there. And then even in question 8 there, Pythagoras comes up in the cone question actually. At the middle of a cone, Pythagoras can often come up working out the slant of a cone or the height of a cone. Question 8 there in 2022. Pythagoras, SOHCAHTOA come up in there. Cosine rule comes up in question 9. And I don't see the sine rule anywhere there, but it could have come up as well. I might have missed it. So the majority of years they all come up in some shape or form at some stage. You'll see Pythagoras comes up there in question 5 as well that year at the end. So 2021 then, so cosine rule comes up in part C of question 8, sine rule comes up in part B, and SOHCAHTOA comes up as well in question 9. And I can't see Pythagoras that year actually, but I'm sure it comes up somewhere. Then in 2020 you see SOHCAHTOA and sine rule come up in question 7. And sine rule comes up there in question 5 as well. So each of them are important to know. Any of them could come up, or all of them could come up, but definitely 2 or 3 of them are guaranteed to come up in the paper anyway, or almost guaranteed. So that's all the trigonometry. So break it down for yourself. Do Pythagoras, SOHCAHTOA, sine rule and cosine rule. So learn off how to do each one and just know how to use the rules in each one, and it'll be worth it. So trigonometry is a big enough part of the paper. Right, this is expected value. This may only come up as part of a question, but you'll see here, so it's the outcome. So it'll give you a probability and then an out, or money that, it's money that Jenna gets here. So the probability that n comes up is 0.3, but if that happens, she gets €1. So, and then if s comes up, the probability of it coming up is 0.2, but if it does come up, she gets 50 cent, and so on. So this is always just multiplying the probability by the value of money for it. So 0.3 times 1 plus 0.2 times 0.5 plus 0.4 times 0 plus 0.1 times 5. It's just multiplying each one by and adding them all together, and that will give you the expected value then. So here the expected value is less than the money paid in. So it's a simple enough little topic to know. And you'll see there, so it was the last part, it was question D, it was part D of question 10 last year. Then it came up in question 10 the year before as well, in part D as well. And I think that might have been it then. Right, so only a couple left. So I've put cylinder, cone, sphere and sectors here into the one. So knowing the formula for these, so volume and surface area of cone, cylinder and sphere of the first three there is important, and the formula are in the log tables again, so it's not like you're learning off them. And then for sector, it's going to be either the area of a sector or the length of an arc of a sector. So again, you should have, I'm not sure if those formulae are there or not, but this is the question. This is a question came up from last year as well. So the first one, it's just a cylinder. It's a swimming pool, but it obviously looks like a cylinder. Now I think you have to go on and do other stuff within the part A there as well. But you see the first part of it is just working out the volume of the water in the pool. So it's just pi r squared h. So that's the formula from the log table of the volume of a cylinder. So it tells you that the height of the water there is 0.75. So that goes in as the height, and the 1.2 goes in as the radius. So remember, be careful because they actually give you the diameter there. That might catch out some people. The part C is a cone. Now you have to work out the length, the side L first. Now that's just a right angle triangle in there, and you have to use Pythagoras for that. So that's another place that Pythagoras comes up. So like I was saying, Pythagoras has uses in a lot of different little topics. So within cone questions, so watch out for it. Here is an example of where it comes up. So they ask you to find out the slant of the cone, which you actually need then in part 2. So you're using Pythagoras in the first part, doing 0.8 squared plus 1.3 squared and square root. That finds out the L, and then you have to use that as part of the formula. The L in the pi r L in the formula for curved surface area is the slant, so you have to remember that. So it's pi times 1.3 because that's the radius of it, and then 1.53 is what you worked out in the first part. So that, now that's what came up last year. And I think something came up in sectors as well. I just haven't put it in here. But knowing those formulae, being comfortable with them, knowing that R is the radius always, just remember that. And then H is always going to stand for height of whatever shape it is. And now the L, that's worth remembering there for cone, that's always going to be the slant. So the formula in the log tables is just being able to take out the measurements from the shape and putting them into it. And you'll have to do more things than that within the questions as well. It'll be asking you about, if you're pouring something into one of them and how does it change the volume, things like that. But it's a good starting point to know those formulae and be able to sub in numbers into them. So it came up there, question 8 last year, question 8 the year before, volume of a hemisphere actually. That's come up a few times. So hemisphere, you're just going to find the volume of a sphere, use the volume of sphere formula, and then just divide by 2 at the end. That's the simplest way to get your head around it. And then so question 8 in 2021 as well. Volume of hemisphere. Then cone comes up as well, where you have to work out the height. So that's where you'll be letting the formula equal something and solving for h. So it's being able to use the formula again. And then so in 2020, yeah, part A there of question 9. So radius of a cylinder. You find the area of a circle there. Volume of sphere and cylinder comes up in question 9. Then the very last thing I want to show you here is area and circumference of a circle. So this is the question came up last year. You had to find the length of the radius. So obviously you're given the diameter there. The diameter of the small circle in the middle is 12. So therefore the radius of it has to be half of it, which is 6. So that's all you have to do for part A. And for part B, you have to work out the area of the circle. So that's pi r squared. And again, it's in the log tables. All you have to do is just remember that r is 6 and just put it in. So pi times 6 squared gives you the answer there. Now, circumference of a circle is also there. You could be asked about that as well. So that's 2 pi r. So just knowing off those formula and being able to put numbers into them. That's all I'm showing you here. So that's the last topic there. There's a good few of them in this video. But again, all of them are important for paper 2. Those are what I'd start on in terms of revising. Obviously I went through them very quickly, but click into any of the links there or QR codes if you want, and it'll go through the questions a bit slower for you. And obviously if you're still struggling on the topic, go back and revise it. Look back at more exam paper questions, look back through the questions from other years, and just keep practicing. So that's all really. Again, it's not an exact prediction, or it's not information that these things will definitely come up in the summer of 2024, but it's generally a look at what has pretty much come up the last few years repeatedly, and it's just a little bit of advice on what you really should know before going into the exam, or where to start revising at least. So that's it. That's all for the video.